Today's lesson is about congruent triangles. The word congruent means equal. So the word congruent, we pronounce it congruent, means equal. In this lesson, we will learn in which case two triangles are congruent or equal. Now, we have these two triangles, a blue triangle and an orange triangle. Let's discover visually in which case two triangles are congruent. You see this orange triangle. I will try to place it on top of the blue triangle and let's see what will happen. If you notice here, they are a perfect match to each other. If I place them on top of each other, they will match perfectly. And I notice here that these two triangles have exactly the same shape. And visually I can see that all the sides are respectively equal, or the angles are respectively equal. But now our introduction is visual here. We knew visually what do we mean by the word congruent and when two triangles are congruent or equal. Now let's start with part 1, definition. In the previous introduction example, visually we deduced when two triangles are congruent or equal. Now we are going to see, geometrically speaking, when two triangles are congruent. Two triangles are said to be congruent or equal if the three sides and the three angles of the first triangle are respectively equal to the three sides and the three angles of the second. Let's see this example here to understand this definition better. In this example, they are telling us that triangle LOI and triangle RAT are congruent. So here, by looking at the codes in both triangles, we can notice that side LO, don't forget that a side is actually a segment. The side LO is equal to the side RA, same code. Side OI equal to side AT, and the side LI is equal to the side RT. And the angle of vertex O, which is LOI, is equal to the angle of vertex A, same code, RAT. The angle of vertex I, LIO, is equal to the angle of vertex T, RTA, and the angle of vertex L, OLI, is equal to the angle of vertex R, ART. So we have here three sides of the first triangle LOI are respectively equal to three sides of the triangle RAT, and three angles of the triangle LOI are respectively equal to three angles of triangle RAT. So once they tell us that two triangles are congruent, it means we have 6 elements that are respectively equal. 3 sides and 3 angles. In another meaning, 3 pairs of sides and 3 pairs of angles are respectively equal. So the 3 pairs of equal sides, we call them the corresponding sides, and the 3 pairs of equal angles, we call them the corresponding angles. So we already mentioned that OL equals AR, LI equals RT, and OI equals AT by looking at the codes. These are the corresponding sides. We have 3 pairs, and angle OIL equals to angle ATR, angle LOI equals to angle RAT, and angle OLI equals to angle ART. So we have in total 6 corresponding elements. 3 of them are in fact 3 pairs of equal sides, and the other 3 are in fact 3 pairs of equal angles. So here They gave us the fact that these two triangles are congruent. That's why we can say that all these 6 corresponding elements are equal. In the next part of our lesson, we will learn how to prove that two triangles are congruent. And you will notice that we don't have to prove that all these 6 corresponding elements, the 3 pairs of sides and the 3 pairs of angles, are respectively equal. No, we only need 3 elements out of these 6 elements. Now in part 2, we will learn the first case of the congruency of two triangles. In another meaning, we will learn which elements do we need to have, what is enough to prove that two triangles are congruent. So as I said earlier, we don't have to prove that all the 6 elements are equal. Let's read the rule. If in two triangles a side from the first is equal to a side from the second triangle, and the adjacent angles of these two sides are respectively equal, then the two triangles are congruent. To understand what do we mean by this rule, let's look at this example. In this example, we have two triangles with codes. By looking at the codes, we notice that the side AC from triangle LAC is equal to the side EF from triangle DEF. So here we know that a side from the first triangle is equal to a side from the second triangle. We also need to have the fact that the adjacent angles of these two sides are respectively equal. Let's explain first what do we mean by adjacent angles of a side. Let's choose side AC. We know that a side is in fact a segment, and any segment has two extremities. The extremities of the side AC are point A and point C. To know which angles are adjacent to the side AC, we look at the angles of vertex, the extremities of the side AC. It means the angle of vertex A and the angle of vertex C are both adjacent to the side AC. In another meaning, angle LAC and angle LCA are the two angles adjacent to the side AC. But here, angle of vertex L, it means angle ALC, is not adjacent to the side AC because point L is not one of the two extremities of the side AC. If we take, for example, the side LC, the two angles adjacent to the side LC are in fact the angles of vertex L and vertex C. Angle ACL and angle ALC are both adjacent to the side LC. In triangle DEF, the two angles adjacent to the side EF are in fact angles of vertex E and of vertex F. So angle DEF and angle DFE are the two angles that are adjacent to the side EF. So to prove that two triangles are congruent, we need to prove that one side of the first triangle is equal to one side of the second triangle. Here, we don't know anything about the sides LA and LC, DE and DF because no codes are placed and we don't have any information that are written aside. So we don't know anything about these two sides. By looking at the codes, we know that AC equals EF. Now let's see what are the angles that are adjacent to the side AC and the angles that are adjacent to the side EF. We know that the two angles adjacent to the side AC are of vertex A and of vertex C, and the two angles that are adjacent to the side EF are the angles of vertex E and of vertex F. And by looking at the codes, we notice that angle LAC is equal to angle TEF, and angle LCA is equal to angle DFE. And by looking at the rule, we know that all the needed elements are available here to prove that these two triangles are congruent. We have one side of the first AC is equal to one side of the other triangle EF, and the two adjacent angles to side AC are respectively equal to the two adjacent angles of the side EF. So in conclusion, in this chapter, to prove that two triangles are congruent, we need to prove that they have one equal side included between two equal angles. And these two equal angles are in fact the angles that are adjacent to both these equal sides.